Alright, so this is number 56 from 10.3, and it's asking to find the slope of a tangent line to the polar curve r equals 2 plus sine 3 theta at theta equals pi over 4. I've written the formula in orange here. The formula may look somewhat ugly at first glance, but if you examine it a little bit more closely, while keeping in mind the Cartesian polar conversion here, you'd notice that it's actually really just saying dy d theta over dx d theta. And then from there, dy d theta, you just look at this y expression here and do the product rule, and then similarly for the x expression, do the product rule because r is a function of theta and it's not just a constant. So, given that, once you just use the formula, it's really just computation. So let's first compute this dr d theta portion that pops up 2 times, and then we'll plug it into the formula. So, dr d theta is the derivative with respect to theta of 2 plus sine of 3 theta, which is our r, which is equal to 0 plus 3 cosine theta, 3 theta. Using the chain rule, and that's just 3 cosine of 3 theta. Okay. And then from there, let's just plug it into the formula. So dy dx is equal to, alright, this may get somewhat ugly, 3 cosine of 3 theta times sine theta plus, and then our r is just what they gave us, 2 plus sine of 3 theta cosine theta times cosine theta all over 3, again, cosine 3 theta for dr d theta times cosine theta plus, minus r, 2 plus sine of 3 theta times sine theta. Alright, from there they gave us theta to be what? Pi over 4. So let's just evaluate the expressions that we're going to need. So we're going to need 3. We're going to need that here and a few other places, and then we're going to need sine of pi over 4. We're going to need cosine of pi over 4, and we're going to need cosine of 3 times pi over 4. So these all pop up in a formula, so let's just evaluate them. Now you could plug that into your calculator in radian mode, or you could use the unit circle, which I'm going to opt to do here. So pi over 4, and this is one of those common angles anyway, pi over 4, so the cosine component of that is going to be root 2 over 2, and the sine component of that is going to be root 2 over 2. Root 2 over 2, root 2 over 2, and now for 3 pi over 4, so this is pi, the entire top is pi, so this entire thing is 3 pi over 4. So it should have the same sine value, so, I wrote this down twice. This should be sine. How do I get this up? Sine. Okay, so they have the same sine value, so root 2 over 2, because it's in the positive y quadrant in both cases, pi over 4 and 3 pi over 4. But for the 3 pi over 4 cosine, it's in the opposite direction for x, so it's negative. Negative. Alright, and from there, let's just plug it into our formula. So dy dx is equal to 3 times cosine of 3 theta, which is negative root 2 over 2, times sine theta, root 2 over 2, plus 2 plus sine of 3 theta, which is root 2 over 2 again, a lot of root 2's, times cosine theta. Well, guess what that is? Root 2 over 2. Phenomenal. Over, and then 3 times cosine of 3 theta is negative root 2 over 2. Cosine theta is root 2 over 2. Minus 2 plus, and then sine of 3 theta, root 2 over 2. Sine of theta, root 2 over 2. Well, that looks pretty darn close. So let's see, we've got those cancel, so we're left with 3 halves here, plus root 2 plus 1/2 over negative 3 halves, let's see, minus root 2 minus, well, what's that one? 1/2. So we're left with negative 1/2, negative 1 plus root 2 over negative 2 minus root 2. Or equivalently, if we multiply top and bottom by negative 1, we get 1 minus root 2 over 2 plus root 2. And that is the final answer. So just kind of computationally dense, a little arithmetic at the end, but that is the final answer, and it's just remembering this formula. Yep.